In 1900, a sponge diver dropped into the Mediterranean Sea off a small Greek island and found something that should not have been there. Not the shipwreck. Ancient wrecks are not unusual in these waters. Not the statues, the coins, the glassware pulled up over the months that followed. What should not have been there was a corroded lump of bronze, barely noticed among the treasures, that when finally examined, decades later turned out to contain a secret that shattered everything historians thought they knew about the ancient world. A machine, built 2,000 years ago, more mechanically sophisticated than anything that would be constructed again for over 1,000 years. And to this day, we do not know who made it, or how, or why it disappeared so completely that the technology was simply lost, as if it had never existed at all. This is the story of the Antikythera Mechanism, and the deeper you go into it, the stranger it gets. The diver was a man named Elias Stadiatis. The island was Antikythera, a speck of rock between Crete and the Greek mainland. The ship was an ancient Roman cargo vessel, shattered on underwater rocks 45 meters down, surrounded by bronze and marble statues, amphorae, jewelry, glassware, and coins. A treasure haul from the ancient world, sitting undisturbed at the bottom of the Mediterranean for nearly 2,000 years. Stadiatis surfaced and told the others. They went back down. For months, they pulled up artifact after artifact, statues that are now among the most celebrated in the world, objects that rewrote what historians knew about Roman-era trade and craftsmanship. And then, almost unnoticed, they brought up the lump. It sat in a museum storeroom in Athens for years. Archaeologists cataloged it, assumed it was some kind of navigational instrument, probably from the Renaissance, because nothing from the ancient world, as far as anyone knew in 1900, could possibly be this mechanically complex. Then in 1902, a researcher named Valerios Stais looked more carefully than anyone had before. Inside the corroded bronze, gears, dozens of them, interlocking, precisely cut, nested together in a system of extraordinary sophistication. Stais suggested it might be an astronomical clock. His colleagues dismissed the idea almost entirely. Ancient Greeks, for all their documented genius, simply could not have built something like this. Could they? What survives today is roughly a third of the original device. 82 fragments of corroded metal examined using every non-invasive imaging technology that modern science has produced. X-ray imaging, CT scanning, polynomial texture mapping. Antikythera Mechanism is a hand-cranked mechanical calculator. You turn a handle, and a system of interlocking gears drives a series of dials and pointers across both the front and back of the device. On the front, a large circular display tracked the movements of the sun and moon through the zodiac. On the back, two large spiral dials, one tracking a 19-year lunar calendar, the other a 76-year cycle, reconciling the lunar and solar calendars with extraordinary precision. Smaller dials tracked the 4-year cycle of the ancient Greek games, including the Olympics, and a mechanism on the front predicted solar and lunar eclipses, telling the user not just that an eclipse was coming, but what color it would appear in the sky. The gearing includes epicyclic gears, gears mounted on other moving gears, generating mathematical relationships of extraordinary sophistication. Some gear teeth are less than a millimeter long, cut with a precision that has no parallel in anything else surviving from the ancient world. To produce gear teeth that small, with that level of consistency, from bronze, using the tools available in the 1st century BC, the engineering skill required was thought to be impossible for this era. The kind of precision manufacturing that would not be seen again for over 1,000 years. So who achieved it? And why did that achievement leave almost no trace? In 2024, researchers Graham Wone and Joseph Bailey at the University of Glasgow applied statistical techniques originally developed to detect gravitational waves, the same methods used by the LIGO Observatory to identify ripples in spacetime from colliding black holes, to analyze the mechanism's surviving calendar ring. Their conclusion was that the ring most likely contained 354 to 355 holes, an almost perfect match for the lunar year. This supported the idea that the mechanism tracked time using a lunar calendar with extraordinary precision, a sophisticated astronomical tool of genuine practical value to navigators and astronomers across the ancient Aegean. And then, just months later, in April 2025, a team of Argentinian scientists published a computer simulation that incorporated something earlier reconstructions had consistently ignored: the actual triangle-shaped profile of the gear teeth, combined with the unavoidable imprecision of ancient hand manufacture. When the real geometry of the gears was modeled accurately, including their real-world flaws, the mechanism jammed. Constantly, not occasionally, constantly. One researcher compared it to the worst printer you have ever encountered. Their conclusion was striking and controversial. Perhaps the Antikythera mechanism was never a precision-working instrument at all. Perhaps it was an extraordinarily ambitious showpiece, a demonstration of mechanical genius that looked far more impressive than it actually performed. So which is it? A working astronomical computer of breathtaking accuracy? Or a magnificent but fundamentally flawed mechanical statement piece? 2/3 of the original device is gone, corroded beyond recovery, or simply never found on the seabed. Every reconstruction ever proposed is, to some degree, an educated guess about what the missing sections looked like and how they functioned. Two teams of exceptional scientists using rigorous methods arrived at contradictory conclusions within 12 months of each other. That is not a failure of science. What we can say with absolute confidence is narrower but still remarkable. The Antikythera mechanism is the most mechanically complex object to survive from the ancient world. Nothing of comparable sophistication has ever been found from this era anywhere on Earth. When it was built, nothing like it existed. And after the shipwreck took it to the seabed, nothing like it would be built again for over 1,000 years. Where did the knowledge come from? Ancient sources mention a tradition of mechanical astronomical devices associated with the island of Rhodes, and with the philosopher and mathematician Posidonius, who lived there around the time the mechanism was built. Cicero wrote about a mechanical device that reproduced the movements of the sun, moon, and planets, a description that fits the Antikythera mechanism with uncomfortable precision. But we have no direct evidence connecting any named individual, workshop, or school to this specific object. Its maker is unknown. Its commissioner is unknown. Why it was on that ship, sailing to where, for whom, all of it unknown. The lack of documentation is as striking as the object's complexity. In an era where Greek scholars recorded their work obsessively, how could something this significant leave no trace in the historical record? A highly secretive tradition? A highly localized one? Or perhaps the records did once exist and simply did not survive. The fire at the Library of Alexandria destroyed an unknown number of texts. Could the key to understanding the Antikythera mechanism have been among them? In 2025, renewed excavation of the Antikythera shipwreck by the Swiss School of Archaeology recovered new fragments of the ship's hull. The vessel was built shell first, the outer planking laid before the internal frame, a sophisticated technique that hints at the advanced shipbuilding of this era. But the mechanism's origin remains stubbornly, magnificently unresolved. Think about this for a minute. This is not a mystery from a civilization we know little about. This is ancient Greece, one of the most studied, most written about cultures in all of human history. We have their philosophy, their mathematics, their architecture, their drama, their medicine, their politics. We know their names and their arguments and their gods, and yet they left no record of how, why, or who. It appeared on a ship, it sank, and the knowledge that created it vanished so completely that for over 1,000 years, nobody built anything remotely like it again. We assume, almost instinctively, that human knowledge moves in one direction, always forward, always accumulating, progress as a straight line. But this object is evidence that the line bends. That brilliance can appear and disappear without leaving a trace. That knowledge can be achieved at an extraordinary level and then simply lost, entirely, as if it never existed. We do not know their names. We do not know their city. We only know that once, somewhere in the ancient Mediterranean, someone held the movements of the cosmos in the palm of their hand, turned a handle, and watched the gears move the universe. Next week, we ask a question that reframes everything you thought you understood about human extinction. Because new research suggests that when the Neanderthals disappeared from the Earth, it was not disease. It was not climate change. It was not that we were stronger or more violent or smarter. Scientists now believe the answer is something so quietly devastating, so deeply and recognizably human, that it will change the way you think about what it means to belong. That is our next video. And the answer is not what you expect. Calibrated Past, where ancient evidence meets modern science.